This week in AI. Number 1. Claude admits failure while GPT hallucinates. Number 2. Grok trails only Fable in coding test. Number 3. Anthropic details the Claude Code agentic loop. Number 4. Why delayed LLM evals trigger incidents. Number 5. Anthropic extends Claude Code rate limits. Number 6. UI concepts visualize AI reasoning effort. Let's get into it.
AI researcher Riley Goodside ran a vision test on what appear to be hypothetical future versions of OpenAI and Anthropic models. He fed them an image of meaningless scribbles drawn with his eyes closed and asked them to read the handwriting. The GPT model confidently hallucinated a transcription, while the Claude model admitted the text was illegible. This test highlights a fundamental philosophical difference in how the two leading AI labs align their models. OpenAI tends to optimize for helpfulness, pushing its vision systems to find patterns even in sheer noise, which results in confident hallucinations when the input is actually meaningless. Anthropic optimizes Claude for caution and honesty, training the model to recognize its own uncertainty and refuse a task rather than guess. As multimodal systems are integrated into critical workflows like medical imaging or legal document analysis, this divergence matters. A model that admits ignorance is safer for high-stakes environments, whereas a model that always guesses risks introducing fabricated data into automated pipelines.
Elon Musk recently shared a performance update regarding the capabilities of his artificial intelligence company's flagship model. He stated that Grok has secured the second-place position, sitting just behind Fable, in evaluations measuring real-world software engineering skills. This ranking points to performance on rigorous coding benchmarks that test an AI's ability to resolve actual GitHub issues, rather than writing isolated text snippets. Placing second behind Fable implies Grok is demonstrating the advanced reasoning required to navigate complex multi-file codebases, understand existing software architecture, and implement functional patches without breaking other system components. The focus of AI development is currently shifting away from mere conversational fluency toward autonomous behavior, where a model can operate like an independent junior developer. If Grok can reliably execute these multi-step engineering tasks, it signals that XAI is rapidly closing the capability gap with established industry leaders in applied enterprise utility. A recent post by developer PrecisoX highlights a new educational release from Anthropic focused on loop engineering. The post outlines a free course that explains how Claude Code operates under the hood, specifically detailing the mechanics of the agentic loop and a function most developers overlook. The agentic loop is the underlying architecture that allows an AI like Claude to move beyond simple call and response interactions into autonomous problem solving. Instead of generating a single output and stopping, the model continuously evaluates its own progress, queries external tools, reads the results, and decides on the next logical step without human intervention. By publishing the exact mechanics of how Claude Code executes this continuous cycle, Anthropic is giving developers the technical blueprints required to build systems that can independently debug, write, and test software. This effectively shifts the engineering focus away from writing static prompts toward designing continuous, self-correcting feedback cycles within the software itself. Open-source observability platform Langfuse is calling out a dangerous habit among AI engineering teams. They point out that developers constantly delay building evaluation systems for their language models, a decision that almost always precedes a major quality incident. To fix this, Langfuse launched a free academy teaching proper evaluation techniques. In traditional software, unit tests provide predictable pass or fail results. Large language models do not output deterministic text, meaning standard testing frameworks fail to catch hallucinations or degraded reasoning. Teams often rush to production, relying on superficial vibe checks rather than building robust automated evaluations. Creating these evals requires curating golden datasets, defining scoring metrics, and using another model as a judge to grade outputs at scale. When teams skip this infrastructure, they fly blind.
A minor prompt adjustment or an underlying model update can silently break the application's logic in production. Langfuse's initiative highlights that scaling AI requires mathematically proving a model's reliability before it ever reaches end users.
The official Claude account on X recently announced a temporary update for their active subscribers. Anthropic is extending access to the Claude Fable 5 model across all paid plans. They're also maintaining the 50% increase to weekly rate limits for Claude Code through July 19th. This extension indicates that Anthropic is currently managing the substantial compute load required by their agentic coding tools. Claude Code operates directly within a developer's local terminal to read files, write code, and execute commands. This level of autonomous operation heavily consumes API tokens, causing users to rapidly hit standard usage caps. By sustaining a higher rate limit for another month, Anthropic provides software engineers the necessary overhead to integrate the tool into actual production workflows, rather than just short experimental sprints. It suggests the company has secured sufficient data center capacity to support intensive developer usage, prioritizing consistent access over strict rationing during a period of sustained demand.
A recent post by Shikar on X showcases a new way users are visualizing control over artificial intelligence systems. The creator shared a conceptual user interface featuring an AI effort slider. The design was generated as an image using GPT and then animated into a video format using a tool called OmniFlash. The concept of an effort slider directly addresses a shift in how modern AI models operate. Historically, language models generated responses as quickly as possible, with a fixed amount of computational power per token. Newer reasoning models introduce variable inference time, meaning the system can spend more time computing a complex problem before delivering an answer. A user-facing effort slider would allow operators to manually balance speed and cost against the depth of reasoning required for a specific task. By prototyping this interface using AI image and video generation tools, creators are anticipating the exact controls developers will need to manage the trade-offs of next-generation compute constraints.
That's the week. One AI story explained in depth every day. Subscribe so you don't miss the next one.